Today I'll be solving the problem tallest around, okay, which is a DSA question. This is a classic sliding window minimum problem where we need to find the tallest person in every group of k consecutive people in in a queue. Okay, so let's go step by step. Let me first explain you the question, what question is saying. Okay, so we are given a queue of L length. Okay, yeah, q of L, okay, which is people, and it is represented by an array A, where each number is the highest of person. Instead of finding the tallest person in the whole queue, we need to repeatedly look at every interval of k consecutive peoples and find the tallest person in the interval. Okay, like let me give you example. Like there is q, this suppose this queue. Okay, 1 2 3 1 4 5 2 3 6. Okay, and k is 3 over here. Okay, and 9 is the length of the array. So then the tallest in each sliding window is 1 2 3. In 1 2 3, 3 is tallest. Okay, 2 3 1, 2 3 1, 3 is tallest. Okay, and 3 1 4, 4 is 4 is tallest. Okay, all of this, 1 4 5, 5 is tallest. Okay, and so on. So the output of this case would be 3 3 4 5 5 6. Okay, because the first three is in first sliding window, 3 is the large tallest. Okay, then in second sliding window, 2 3 1, 3 is the largest. Okay, tallest, I mean. So now let's go through the code. Okay, what we have done in this. So at first, we clean up the input and split it into lines. Okay, in the first line is the number of the test case. Okay, we also use variables line to keep the track of which line we currently reading. Okay, now in this for loop, let's see what we are doing in this. For each test case, we read two numbers. Okay, L, which is the length of the queue, and K, the sliding window size. Okay, then we read the array. Okay, array which contains the highest of people in the queue. Now let's come to this line 10 11 and 12. Okay, here we declare two array dq, which will help us to keep track of the uh, potential tallest people, and using their indices and result, where we store the final answer to of each window. Okay, for each window. Now let's come to this for loop. Okay, we loop through each person in the queue. If the front index of the dq is outside the current window of the size k, we remove it from with shift. Okay, now let's come to while loop. What we are doing in this, in this we are remove all the smaller height from the back of the dq, because they cannot be the tallest anymore. Okay, if there are a taller person available. Okay, now next we add the current index to the dq of our window has reached size k. Okay, meaning we are at the least of at the kth element. Okay, and then the tallest person in the current window is at the front of the dq. Okay, so we push that height into the result. And finally, after processing all the windows, we print the result array. We join the element with spaces. Okay, so the output is formatted correctly. So the time complexity of this approach is O of L for each test case, because each person index is added and removed from the DQ at the most once, and this is much faster than a naive OLK solution, where we would can scan each window separately. The space complexity is O of k, since the DQ at the most holds k indices. Okay, so that's how we solve the tallest round problems using a DQ based sliding window maximum approach. Okay, it efficient, elegant, and work perfectly for the large queue. uh, now we let's move to the second question. So okay, second question we are going to discuss about the large pair point. Okay, so um, in this question the idea is to find the best pair of the indices I and j in two array. Okay, uh, to minimize a particular formula. Okay, we will go to step by step and also explain how to do this efficiently in a linear time. Okay, so what question is saying, we are given the two array, okay, at the same length and the nums are strictly increasing integers and value are the integers that can be negative or positive. Okay, so we need to find the pair ij where I is less than j, that minimize. Okay, then we return that the maximum value. So the sample output is given. Okay, input is given like the nums 016 and the value is -554. Okay, so we compute all the valid pairs like if I is equals to 0 and z is equals to 1. Okay, then it will be -5 plus 5 plus 1 minus 0 is equals to 1. Okay, like like in the second also, I equals to 0, j is equals to 2, minus 5 plus 4 plus 6 minus 0 is equals to 5. Okay, and then so I is equals to 1, then I is equals to 2, then 5 plus 4 plus 6 minus 1 is equals to 14. So the answer is 14. Okay, now the code explanation. Yeah, so in the first, we clean the input. Okay, and size of the array, and then we parse the num and value from the array string into number. Okay, then max left keep track of the best value of the value I minus num I. Okay, so, which we've seen so far. This help us to minimize the expression efficiently. We also initialize results to a negative infinity. Now in the for loop, we loop through j from 1 to n minus 1 for each j. Uh, the best I do before j is already stored in the max left, so we compute the candidate is equals to max left plus value j plus num j. Okay, and then we update results candidate is bigger. Finally, we update the max left using the current j for the next iteration, and at the end we are going to print the result. Okay, which is the maximum value we found. Okay, and that is the answer, that is our answer. Okay, so the key observation is writing the expression as value I minus num I. Okay, plus value j plus num j. Okay, so for every j we only need the maximum value I minus num I for I less than j. That reduce a native of o n by power 2 solution of o n times, and the space complexity is o of 1 since we only track a few variables. Okay, so in this way we have solved this question also. So I hope you understand it. Thanks for watching my video. Thank you.